Yeah. Good morning, students. Will you able to hear my voice? Hello.
Yes, sir.
Yeah. Okay. Fine. I want to introduce myself. I'm Professor Krishna Fatehpur.
Sir, there is only one student in the
Yeah.
class.
No problem. Today's class. It is the first class. Okay. I can't. Are you
Okay.
comfortable now?
Thank you.
Are you comfortable?
Yes, sir.
Okay. Fine. I'm probably I may be new to you. That is new to you, but not to this college. Actually, I joined to this college in the year 1998, and I passed out my MS. Hello. Hello. Hello,
Yes,
Aprame.
sir. Yes, sir.
Will you able to hear my voice? Can you able to hear my voice? Can you hear my voice? Hello.
Yes, sir.
Yeah. Okay. Fine. Now, I think now students are gradually they are admitting now. No problem. Now, almost 34 years of service I'm having. That it is my introduction, and I completed my MSc in solid state physics. Okay. For 2 3 years I was not in this college. I had been to some other place here for the deputation basis. Again in the month of February, I came back to this national college. Okay. If any, suppose if you're inconvenient, sorry, hello, hello. If my voice is not audible for you, please, hello, tell me, hello. Okay. Now, please disturb me that, or you send your SMS. Suppose you if you're not comfortable with my voice and all that. Okay. Now for this semester, for 4 semester, I supposed to teach that is laser chapter. That is laser chapter here. Okay. In the laser chapter, a very interesting one here. Here the introduction of laser is there, principle of laser, kinds of laser. Then again it is repeated. Population inversion mechanism, optical pumping, helium neon gas laser, semiconductor laser, and then applications of what? Laser. This is the content of the laser chapter. Okay. Students, you will ask a question where the people are using laser. Please don't ask the question where they are using. Don't ask the question. It is better to ask the question where they are not using. I think you can able to understand this my words. That is, don't ask the question where they're using. It is better to ask the question where they are not using. It means the laser beams, the laser technology, it is used in what? In all industry. It may be medical industry, or it may be mechanical industry, or it may be communication industry. Everywhere the laser is there. I think you know that laser printer, you know that. And earlier that is what the CD writer was there here. Okay. And all operations, that is what any cataract operations is there, that is also what through the laser only, that is laser operations. And if you visit any mall and all that, there is a scanning is there. Now that scanning is again is based on the what? The laser. So that the laser has got its own applications, large applications in every different domain. That is okay. Fine. First, laser properties. Laser properties are what? First, before laser, the people they invented the maser, they invented here. Maser, that is. Okay. Here, maser. Maser means microwave amplification by stimulated emission of radiation. What is microwave? What is amplification? What is stimulated emission of radiation? I'll tell you later. First, what is the acronym of maser is microwave amplification by stimulated emission of radiation. You may ask question, sir, why you are explaining the maser but we are having the syllabus laser? Okay. But laser expansion is what? Light amplification by stimulated emission of radiation. That is. The difference between these two is what? This is the electromagnetic spectrum. This is the electromagnetic spectrum. Even in the high school level also you studied, in the PU level also you studied here. It is what? First, radio waves is there, microwave is there, infrared is there, visible light is there, ultraviolet is there, X-ray is there, and gamma rays. Look at the spectrum here. As I move from right to left, I am moving this. First, radio, microwave, infrared, visible means visible reason it is, ultraviolet, X-rays, gamma rays, where the energy is gone, what increases? Energy of the electromagnetic radiation is what increases. First, the people invented the measure in this region here, microwave region. That is. Hello? Hello? People invented first in which region here? Microwave region here. Next, the people invented as technology is improved here, that is in the visible region. That's why it is called as a light amplification by stimulated emission of radiations. I think you can able to understand. The principle in the microwave, principle in the visible region, both are same only. That the mechanism is what? Same only. What is that mechanism? I will tell you later. Now the people invented the lasers in the X-ray region also. X-ray region also. That means the energy of this laser in X-ray region is very high. Next is what? Visible, lower. Next it is what? Very much lower. It is what? Microwave region here. Here, you may ask question what this? This is the wavelength. You see, the wavelength is more. But as I move from right to left, the wavelength is gone, decreases here. This wavelength decreases or frequency increases. As frequency increases, then what happens? You know that energy E equal to 1 minute. Yes. E equal to what? H nu. That means as frequency increases, then what happens? The energy is also what? Increases here, students. As this frequency increases, then energy is also what? Okay. The production of the laser in the X-ray region is very high. The energy of this in the visible region is low, and energy in the microwave region it is a low only. Okay, fine. That's why major expansion is microwave amplification by stimulated emission of radiation. Laser means light amplification by stimulated emission of radiation. Okay. Now see, this comes in the where? This comes in the comes in the which region here? Microwave region. It is in a microwave region. This comes in the what? In the visible region here. Visible region. Fine. Now here, what are the properties of the laser? First I'm discussing. The basic properties I'm discussing here. Highly monochromatic. Mono means single, that is. I think you can able to understand that. It is what? Highly monochromatic. Means single wavelength. Single wavelength. But if you look into the sun spectrum, no, it is not single wavelength. There are many wavelengths are there. Ultraviolets are there. X-rays are there. Okay. Where infrared radiations are there. But the laser is what? It has got single wavelength. Next is highly directional. The word itself indicates that it travels in only one direction. It not changes any direction. It means that the beam is well collimated and travels a long distance with little spread. That is more important for the higher education. Little spread. Some deviation is there, but not immediately, but after traveling several kilometers and all that. Here, by using the laser beam, just to focus it in upward direction by using a high energy beam, I can measure the distance between the moon and earth. I can measure it. I know the speed. I know that is what, after what time it reflected waves I'm getting here. I know the equation velocity equal to distance divided by what? Time. From that equation, I can calculate the distance between the earth and moon. I can calculate it is because of a highly directional one. Students, 1 minute. Here I'll show you that is highly directional. See? This is the ordinary light. Ordinary light. Your torch, you see how the light spreads. Now, see, The light is spreading, that is. And it will not travel the longer distance. But if you look into the laser light here, you see highly collimated here, highly collimated. And it can, without any spreading, that is, without any spreading. But of course, the spreading is there, about 1%, 2% spreading is there. But it is after traveling a several kilometers and all that. This picture shows that the laser beam, the property is what? Highly directional one here. I think it is clear for you, that is. Okay. Now, next, highly coherent. See, there is a new word, that is coherent. Means the coherent indicates the phase of all the particles are same. Phase of all the photons is what? Same. It means all individual waves of light are moving precisely together. That means, imagine yourself, you and your friend, you are traveling, that is, you are moving, that is, you are walking in the garden. If you put one step forward, your friend is also putting one step forward. If you are putting two steps forward, he is also putting two steps forward. That is, there is a highly coherence is there between you and your friend here. There is no any phase line. There is no any phase line here. I will show you one picture. That is here. Coherence, you see. Here you see this line I don't know. This is the maxima. This is also what? Maxima. This one way. First photon, second photon, third photon, fourth photon, fifth. All photons you see it at the same time, it is showing the maxima, that is. It is showing the maxima. And after the same time interval issue, you see that is all are what? It is a maxima, that is. It is a maxima, that is. Or else, I will draw this diagram, that is now. But I will draw one line, I will try. You see, here, of course, I have not drawn properly. You see, the minima, that is minima. Minima. After same time, it is minima at this position, minima at this position, minima at this position. Here, all particles acquire the minima or maxima at the same time. Like the several photons are there. Or else we can say that several in the military march fast. Very good example, that is. All that is in the military, that is what when they are doing the march fast, all this what all are together, they are what? They are moving in one direction. But here, incoherent, you see, that is what is incoherent, that is in the incoherent, what happens is here, see, this is maxima, but at the same time, you see here is minima is there, minima. There is no proper, that is minima and maximum, all photons. One will be in the forward direction and one will be what is lagging and all that. It is a very good example for the coherence and all that. Look into this. This is the photon 1, you see, photon 1. It is the minima. But at the same time, for the photon 2, you see, it is a maxima is there. Again, for the photon 3, it is a minima. And it is for the photon, it is maxima is there. But they are not. You see, look into this here, in this diagram. All are what? Here, if I draw one line, you see, they are not in phase. This is the property where you are observing in ordinary light. It may be incandescent bulb, tube light, or any CFL bulb, where there you are observing such kind of property you are observing. This is nothing but what? Coherence, that is. Next, here, because of coherence only, you see now, it is highly intense. Highly intense. Intensity depends upon the number of photons. Intensity depends upon the number of photons. If number of photons are more, then the intensity of the light is also what? More here. See? Here, all photons, they are in the what? Maxima. Intensity is what? It is more here. This is the another property of the what? The laser. I will repeat once again. What is that? Highly monochromatic, highly directional, highly coherent, and highly what? Intense the beam is there. It is the property of the laser light. Okay, fine. Now, here that is, let's see, the timeline of the laser I made. Here, all this laser now that is produced, it is under the mechanism of what? The interaction of radiations with matter. I'll discuss it within 3-4 minutes. I'll discuss it. That is purely, it is based on the what? Einstein's theory. He explained this theory in the year 1927. The entire laser mechanism, it is completely is based on the what? Einstein theory. That theory was proposed in the year 1927, students. Based on this only, look into this. They invented in 1958 by Tonus, is the name of the scientist, in Bell Laboratory. Bell Laboratory is the, till now, it is very richest laboratory, and whatever the new inventions are taking place now, in the Bell Laboratory only is taking place. Any new IC, what it is, any new invention about the nanomaterials, what all technology, completely it is taking place in the Bell Laboratory. Who invented the first, the maser was invented by whom here? Tonus, in the year 1958. For that, he obtained the Nobel Prize. He bagged the Nobel Prize in the year 1964. He obtained, he got, here is a recipient of the Nobel Prize in the year 1964. Of course, you see, within 6 years, he received the Nobel Prize. And in the history of the physics, and not only in the history of physics, even in the chemistry or in the biology, that is, many of the scientists, now they are invented after 30, 40 years, they will receive the Nobel Prize. There are cases, some of them, they get the Nobel Prize when they are at the edge of the deathbed, they are receiving. Of course, the Tonus, he received the Nobel Prize in the year 1964, he received here. Next, third one, that is, the solid state ruby laser. It is a solid material, ruby. I'll tell you what is ruby and all that later. It is an aluminum and then chromium metals. That is mixture is there. That is different one. Don't worry about ruby laser and all that. This is the solid laser. This is developed by whom here? Mayman. That is Mayman. On this principle, same principle is same, but he obtained in the year 1960. He designed this one. And this one in the year, which one here? First laser, 1958. It is what? Maser. Next is what? The first laser is what? A ruby, that is solid state laser. It is invented in the 1960. Students, you might ask question that what is the example? Which maser they invented? First maser they invented is ammonia gas, NH3, that is. NH3, that is. And in the laser history, the first one is what? A ruby, that is. Next one is the popular laser. You have seen that in the market and all that. Helium neon gas laser. It is a red in color. It is invented by whom here? Ali Jawan is the name of the scientist and others in the same Bell Laboratory in the year 1961. That is. Students, always the great scientists, what they will do is always they will open the big doors, the new doors they will open. That is. The laser was it is a new door in the history of the physics and all. Whenever any person who opens a new door now, definitely is eligible to get the Nobel Prize and all. It's a new door. Of course, till today, the many of the Nobel Prizes are awarded and all that here. The many of the PhDs are produced here. Thousands of papers are published in the laser and all that. Next one is. Okay. Now I'll come to that. The interaction of radiations with matter. Why I'm discussing is all your laser mechanism is based on this principle only, that is interaction of radiation with matter. This theory was proposed by whom here? Our great scientist Einstein in the year 1927. Students, the time scale is also very important. He explained theoretically in the year 1927 and they realized that practically in the year which year? 1958. You see, 1958. That theory was utilized in the production of the maser or laser. Almost what? More than nearly about 30 years the people took to realize the laser. It is based on which theory here? Einstein's theory. Interaction of radiation with the matter. This theory strongly supports the double nature of light also, students. Okay. What are the three? It is important from the point of examination. First one is stimulated absorption. That is, I'll tell you what is stimulated absorption. Spontaneous emission, stimulated emission. I'll tell you one by one here. Listen carefully. Now, what are the three interaction of radiation with matter? One is stimulated absorption. Next is spontaneous emission. Next is stimulated emission. I tell you within 5 minutes what is the difference between here also emission is there, here also emission is there. But this is spontaneous emission, but this is what stimulated emission is. Okay, now first spontaneous absorption is. Okay, fine. Here the Bohr is also received the Nobel Prize. The first successful atomic model is what Rutherford atomic model. For the first time in the history of the physics, the Bohr said that there is an existence of well-defined discrete energy levels. There is an existence of what? Well-defined discrete energy levels. You know that. One level, second level, third level, fourth level, like that. Here, this level I will call it as a what? E1. This is what? E2. This is what? E3. This is what? E4. Like that. The number of what? The lines are. Number of discrete, well-defined energy levels. This is the concept who explained here. Bohr, for the first time, he explained the concept of well-defined discrete energy levels. He explained here. Now, 1 minute. Okay. There is a 1 minute. Here is. Okay. Now, here for the easiest purpose, I consider two energy levels. I consider this is E1 and this is what? E2. This is called as what I will call it the ground state. I will call it as. Then this I will call it as what? First excited level. I will call it as. Normally in the apartments and all that in the multi-story building, you are calling it as a ground floor, first floor, second floor, third floor. No, like that. Here, this is the what? First one is ground floor or ground state. It is called as ground state. Ground state. This is called as first excited state. First excited state. Suppose if there is another level is there, then this I will call it as a what? Second excited level. Second excited state. Ground state. This is called as in what? Ground state. This is called as in what? First excited state. And this is called as in what? Second excited state. And all that. Okay. Now, say. Now, here I was thinking about absorption, that is. Even we can discuss it on this also, atomic orbits, that is. At the center, what is the nucleus is there. This ground state now, this energy is very low, that is. Energy is low. I will take that. This energy is 2 electron volt. This energy is what? 6 electron volt. Okay. In the beginning, all atoms are in the what? In the ground state only, that is. In the ground state. Suppose atom is present in the ground state. Now ground state. Okay. Now it is in the ground state. As long as atom is present in the ground state, its energy is 2 electron volt here. As long as electron is present in the ground state, this energy is how much? 2 electron. If I want to place the atom in the first excited level, this is 6 electron volt. Then I have to supply some energy. I have to supply it. That energy h nu is equal to the difference between E2 and E1. Difference between E2 and E1. This E2 and E1 difference is how much it is? 4 electron volt. Unless I supply the 4 electron volt here, that is, I should supply, how much I have to supply here? 4 electron volt I have to supply. This is the right frequency. That is. When I supply the photon of 4 electron volt, what happens now? The atom will be jumps from this state to what? This state. From the lower state to what? Higher state, it will jump. That's why I will call it as a what? Absorption mechanism. It is called as a what? Absorption mechanism. Here I made one mistake. It is not spontaneous emission. It is called as a stimulated emission. Please note on that. It is stimulated emission. Because atom itself is not going. I have to stimulate. I have to stimulate to go from the lower state to what? Higher state. Then for that, I need to supply how much here? 4 electron volt I need to what? Supply it. That's why. Now look into this definition. The definition is what? The process of exciting the electron. The process of exciting the atom, not electron, atom to what? Higher energy state by absorbing the stimulated right energy photon. Student, that is important. Right energy photon is important, students. Here, highlighter, that is stimulated the right energy photon. That is important. Even if you use 4.1, it will not go there. It is as good as what? You are going to the cinema theater where the different tickets are there. 100 rupees is there. Next is 250 rupees is there. Now you already purchased 100 rupees ticket. Later, you think that I don't want to sit in the 100 rupees, but I want to sit in the 200 balcony. That is. Unless you shell out another 150 rupees, you can't go to the what? Balcony. That is. Already purchased 100 rupees ticket. Again, you have to shell out what? Another 150 rupees. 100 plus 150 equal to what? 250. Then only you can go to the what? The higher level you can go. Okay. Here, that is. Look at the definition here. Normally, they will ask these definitions. The process of exciting the atom to higher energy state by absorbing the stimulated right energy photon is known as a stimulated absorption of radiation. That's why here I made mistake. It is not spontaneous. It is what wrongly. Here, this is this stimulated. You read it as a stimulated here. That is okay. Stimulated. Okay. This is absorption. Next is students. Next mechanism. Spontaneous emission. That is next one is spontaneous emission. The word itself indicates that emission means the transition of the atom from higher energy state to lower energy state. Transition of the atom from higher energy state to what? Lower energy state. As I told you, that is, this energy is very high. This energy is low here. Now, atom is undergoing the transition from higher orbit to what? Lower orbit. Here, you see, now, this energy is 6 electron volt. Sorry, 1 minute. 6 electron volt. This energy is what? 2 electron volt. Now, the atom will be what happens now? It is jumps from the higher state to what? Lower state it jumps. That jumps from higher state to lower state. During jumping, it should lose an energy E. 1 minute, I'm using E equal to what? H nu equal to what? E2 minus of what? E1. This is equal to 6 minus of 2 equal to what? 4 electron volt. You see, this is the photon. This is the photon. What is the energy of this? 4 electron volt here. 4 electron. Unless it loses 4 electron volt, it will not come back to what? Lower energy state. Lower energy state, it will not come back. It should lose an energy, that is. This is called as an emission. But student, remember here? Here atom voluntarily itself it is coming from higher energy state to lower energy state. Voluntarily itself it is coming. Depending upon the, based on some situations where atom itself it is undergoing transition from higher energy level to what? Lower energy level. That's why it is called as a spontaneous emission. That is. Here you see it. Another beautiful property is that any atom in the higher excited state, no, it will not stay for the longer period. It will not stay in higher energy state. The lifetime of the atom in the higher energy state is very, very low. That is. I'll give one example. Normally, the students in the classroom, they will prefer the last bench. The last bench is more stable for them. That is, last bench is more stable for them. It is just like a ground state here. Ground state. I think you can able to understand this analogy that what I gave here. The lower energy level, no, where atoms are comfortably, they will stay for the longer period. In the similar case, in the classroom also, the students are more comfortable always in the last bench. Even forcibly, if ask them to sit in the front bench also, they will not sit much time. That is always in the disturbed mode only. It is like that. This is a spontaneous emission. Okay, what is that spontaneous emission? The transition of excited atom. The transition of excited atom by itself. That is more important, students. By itself here. By itself. By itself. By itself. To what? Lower energy level is known as what? Is known as spontaneous emission. I'll repeat once again. The transition of what? Excited atom by itself to what? Lower energy level is known as a spontaneous emission of what? Radiation. Okay, fine. Next one is another mechanism. What is that mechanism? Stimulated emission here. Stimulated emission. Of course, emission means always mechanism is taking place from higher energy level to what? Lower energy level. From excited level to what? The ground state. By what mechanism? Stimulated. One has to push. One has to push the atom. Suppose saying that atom is here. One has to push externally, go to the what? Ground state. That's what it is called as in what? Stimulated emission, students. I'll tell you this now how it is. Suppose atom is one minute. Atom is here, that is atom is here. Now I'm using the external photon. I'm using the word the right frequency, right energy I'm using. Why I'm using these words, I'll tell you later. This is the incident photon. This is the incident photon or external photon of energy h nu equal to E2 minus of what? E1. This energy, 6 electron volt. This energy is what? 2 electron volt. Here, I have to take the photon of difference is how much? 4 electron volt. 6 minus 2 equal to what? 4 electron volt photon I have to take here. That's 4 electron volt. 4 electron photon. When it incidents on this, no, that is. Now, you are getting the 2 photons are emitted here. You see, the 2 photons are emitted. Both photons are having the same energy, 4 electron volt. This is also what? 4 electron volt. See, in the picture also I shown that is. Both photons are traveling in the what? Traveling in the laser pointer. I'm using here 2 photons. One is what? This is called as what? Incident photon. These are what? Emitted photons. One is this and another one is what? Because of transition. Both are having the same energy. And another point, remember students here, both travels in the same direction, that is. Both travels in the same direction. This is the difference between a spontaneous emission and a stimulated emission. In the spontaneous emission, what happens? Atom itself is voluntarily, it is moving from higher energy state to what? Lower energy state. But in case of stimulated mechanism, using the external agency or any external photon, you are making the atom to travel from higher energy state to what? Lower energy state. So that During the transition of one atom, you are getting what? 2 photons are you are getting. And both energies are same. And both are traversing the what? Same direction. This is the principle what is involved in all the maser production as well as in the what? Laser production. Here, I told you that is the excited atom after getting stimulated by the incident photon. The excited atom after getting stimulated by the what? Incident photon of suitable energy. That's a key word to it. If this word is not present, normally they will not give any mass for it. Suitable energy. This is important, students. This is suitable energy. Keyword suitable energy. The transition of the atom will be taking place from higher energy state to what? Lower energy state here. To lower energy state by emptying how many photons here? 2 photons is known as a stimulated emission of radiation. Okay, fine. Now, I think in the laser acronym, what is the laser acronym? That is expansion I told you that is light amplification by stimulated emission. This is the mechanism you are using. But now I want to answer amplification. Amplification. And light means what? Because it comes in the where? The light comes in the where? Which region here? In the visible region. That's why it is called as in what? Light. And mechanism is what? Stimulated emission. Now I want to answer amplification. What is amplification? I'll tell you now. Whiteboard. No, 1 minute. Whiteboard. 1 minute. 1 minute. 1 minute. Okay. Here, whiteboard. Okay. Here you say why I'm using the word the amplification. Here first it is one. Sorry. Now using one photon, how many photons are you obtained here? That is, you are getting what? 2 photons are obtained. Students, next time these 2 photons, what they will make is it will induce the transition in 2 atoms here, in 2 atoms. As a result, what happens now? Because of this photon, you are getting what? 2 photons. You are getting. Because of this photons, again you are getting what? 2 photons. Totally how many photons here? 1, 2, 3, 4. Your journey started with what? 1 photon. 1 photon to what? 2 photons. Next is what it is? 4. Again, each photon will be induce the transition in another atoms here. So that it will be 1, 2, this one. For this, 1, 2. For this, 1, 2. For this photon, 1, 2. Totally 1, 2, 3, 4, 5, 6, 7, 8. How many photons you are getting? 8 photons. There is a geometric progression is that. 2, 4, 8, 16. That is what? Like this. In this fashion, what happens now? The amplification of the light is continuously taking place here. That's why it is called as what? Light amplification by stimulated emission of radiation. Students, I hope that things are clear for you guys. Okay. Now I'm going to ending the session now within another 2-3 minutes. Tell me now if you have any doubts. Please interact with this. Please. Okay, send your not stop sharing. You just let them ask that question. Why you are sharing? Don't stop it. No, this. Okay. Now, please discuss with me, students. Yeah. Atre, okay. Charan, hello. Kishore, unmute. Okay. Hello. Charan, Monica, please unmute. Unmute. Please unmute. Hello? Unmute.
Hi, sir.
Ah, yes. What is your name? Nandish?
Sudeep.
Okay. Tell me now, are you following or not?
Yes, sir. Following, sir.
Okay. Any problem? Please you tell me that. Don't say good. That is what? Whatever the demerits, what you observed while teaching. It is the first time we are interacting with you now. Yes.
Yes.
Yeah.
Sir, please, can you say portions of your part?
Pardon?
Sir, your part portions.
Part? Portion. Okay.
Yes, sir.
That is, I think, probably it is unit 4, right? Unit 4. You already were having the syllabus copy is there with you?
Sir,
In
no,
our,
sir.
yeah, in our website it is there. Unit 4. Unit 4.
Unit 4.
Yeah.
Sir.
What about that is phase? Any phase lag is there? My sound and what I'm writing the text on the screen.
No, sir. No, sir.
Yeah,
Was good.
that's okay. Any questions?
Sir, no,
Hello.
sir.
What
Sir, no,
about
sir.
no questions? Next is who is there? Next, I won't interact with them because first time. Yes, Charan. No, Charan is not there. Hello, Charan. Sudeep.
Yes, sir.
What is your name? Sudeep.
Sudeep, sir.
Yeah. How do you feel that?